7.4 Partial variation. Here is another kind of variation. Let's see the basic concept. Different form of partial variation. The first one, A. We say that y is partly constant and partly varies as x. So you see that partly. When you see this word, then add up these two parts. Okay? So partly is a constant. I use the unknown k1. Partly varies as x, then k2x. k1, k2 may not equal, so use k1, k2, two constants. Let's see the second one, B. We say that partly varies as x, again partly, and partly varies as y, again partly. So two parts. You see 1, 2, so two parts. One is x, one is y, and here varies as x, varies as y. That means directly. Okay? Let's see the third one, C. Z equals k1x plus k2 over y. Have a look. Partly varies as x and partly varies as inversely as y. So you see the second part inversely as y. Understand? So remember, when you see partly, then separates by the operation plus. Okay? So here, partly varies as x, first one. Partly varies inversely as y, second one. So add up these two parts. Okay? So partial variation consists two or more variation constant. Okay? So you see k1, k2, k1, k2. If more than one parts, maybe three parts, then you have k3. Okay? Now you can try 7.3 checkpoint on page 33 by yourself first. Later on we can check it all together. Okay? Let's see 7.4a first. U is partly constant and partly varies inversely as x. So that means two parts, 1, 2. Okay? And give you some relations between x and u. X equals 2, u equals 5. Okay? When x equals 1 over 2, u equals 11. So find the equation connecting u and x. That means the relation between u and x. Let's see. A. When we write partly variation, please write it directly the equation. For example, here u equals partly constant, right? And partly varies inversely as x. So k2 over x. Here, remind you once again, k1, k2. Two different variation constant. Okay, where k1 not equals 0, k2 not equals 0, k1, k2 are constant. Okay, you have two sets of equation relations because you have two variation constant. That means two unknowns. So you need to have two sets of relations. So 5 equals k1 plus k2 over 2. 5, when u equals 5, x equals 2. Another relations, 11 equals k1 plus k2 over 1 over 2. Right? First equation, second equation. Okay. So the second one minus the first one, then you get that 11 minus 5 equals 2k1, sorry, 2k2, because k1 and k1 cancel out, minus each other. So 2k2 minus 1 over 2k2. So you get that 3 over 2k2 equals 6. So what is k2? Yeah, k2 equals 4. Correct. And substitute back k1, you can find it. And now k2, substitute 4 into it. So k1 equals 3. As a result, u equals 3 plus 4 over x. This is the equation connecting u and x. Understand? B. When x equals 4, what is the value of u? Just substitute, right? So u equals 3 plus 4 over 4. So at the end, u equals 4. Okay, not difficult. When you understand this term is a partial variation, so two parts add up together. And remember, k1, k2, two different variation constant. And here you have the relation between x and u, two sets. So you have two equations now, and solve the equation. Then you get the relation between u and x. After that, find the answer in part B also. Understand?